So the magnetic flux linked with the coil, it depends upon the number of turns in the coil. Now let phi be the magnetic flux linked per turn with both the coils at an instant of time, say t, and Np and Ns be the number of turns in the primary and the secondary coil respectively. Then at the instant t, the magnetic flux linked with the primary coil phi p is equal to capital Np into phi, and with the secondary coil phi s, it is equal to Ns into phi. The induced EMF in primary and secondary coil will be EP will be equal to minus d phi p by dt. So this is my induced EMF in the primary coil due to the change in flux. So EP will be equal to minus d phi p by dt, and it should be equal to minus Np into d phi by dt. So here Np is the number of turns in the primary coil, and Es will be equal to minus Ns into d phi by dt. So if you take the ratio of these two, that is Es upon Ep, then by taking the ratio we get Es upon Ep is equal to Ns upon Np. So this d phi by dt gets cancelled, this minus sign gets cancelled, and therefore we get Es upon Ep is equal to Ns upon Np. The ratio Ns upon Np is called as the turn ratio, or it is also known as a transformer ratio, or it is also known as a transformation ratio of the transformer. So on this transformation ratio, there might be the questions which are asked in the examination. So it is known as the equation for transformer. So for ideal transformer, as I said earlier, that the input power is exactly equal to the output power. So by considering that there are no I square R losses, so for ideal transformer, whatever the input power, all that input power is transmitted by the transformer. So for ideal transformer, input power is exactly equal to output power, and therefore our input power is EP into IP, because EP is the voltage, that is the induced EMF in the primary, and IP is the current which flows through the primary coil. So EP into IP, that is my input power, and it should be exactly equal to my output power, which is equal to ES into IS, where ES is the induced EMF in the secondary coil and IS is the current which flows through the secondary coil. So from this equation, if I write this equation as ES upon EP, then transferring this EP on the right hand side and transferring this IS on the left hand side and rearranging the equation, we get ES upon EP is equal to IP upon IS. So since ES upon EP is equal to NS upon NP, at the same time this ES upon EP is equal to IP upon IS. So since the left hand sides of the two equations are equal, and therefore we can equate the right hand sides, and hence from this we get NS upon NP is equal to IP upon IS, where this NS is the number of turns in the secondary coil and NP is the number of turns in the primary coil, and it should be equal to IP upon IS. So now let us discuss the case 1. So when this NS is greater than NP, that is the number of turns in the secondary coil are more than the number of turns in the primary coil, then obviously if NS is greater than NP, it means that ES is greater than EP. So when ES is greater than EP, it means that the induced EMF in the secondary coil, if it is more than the induced EMF in the primary coil, then it is called as the step-up transformer. And therefore for the step-up transformer, if we look at the equation here, if NS is greater than NP, it means that IP is greater than IS. So the current in the primary coil is more than that in the that in the secondary coil. While look at the case 2, so when this ratio ns upon np is, if it is less than 1, or in other words I can say that when the ratio ns, when this ns is less than np, that is the number of turns in the secondary coil is less than the number of turns in the primary coil, then here if ns is less than np, it means that es is also less than ep. So if the induced EMF in the secondary coil is less than the EMF in the primary coil, it means that voltage is decreased, so it is called as the step down transformer. And obviously if ES is less than EP, then IP is less than IS. It means that the current in the primary coil is less than the current in the secondary coil. So current in primary coil is less than that of the secondary coil. Then one more formula. So all these formulas are important. That is ES upon EP is equal to NS upon NP. This relation is important from examination point of view. Then the relation which is you can simply remember this equation directly, that ES upon EP is equal to NS upon NP, and this is equal to IP upon IS. So based on this relation, there might be the questions which can be asked on this topic. So a lot of questions are they are framed on the formula. Then there is efficiency of the transformer. The efficiency of the transformer eta is defined as, efficiency of anything is defined as output upon input into 100%. So here in case of transformer we deal with the power, that is the electrical power, and therefore here efficiency of the transformer is defined as the output power divided by input power into 100%. So that will be equal to, now output power is the output voltage Vs in the secondary coil, or Es or Vs, that is the voltage in the secondary coil, multiplied by current in the secondary coil, that will be my output power. So Vs into Is divided by Vp into Ip, where Vp is the input voltage in the primary coil and Ip is my input current. So Vp into Ip is the input power. So the efficiency of the transformer is defined as Vs into Is divided by Vp into Ip into 100%. So that is the efficiency. Now let us see what actually takes place inside the transformer. So here this is the primary coil. So when the current flows through the coil, then current carrying coil produces the magnetic field, and therefore the magnetic flux lines will be produced. Now since this is an alternating current or alternating voltage to the primary, and therefore there is a continuous change in the current, the direction of current is changed through the coil continuously, and due to that the magnetic flux lines which are produced inside the coil, that is the primary coil, that will also change. Now since this is made up of soft iron core, and therefore the magnetic flux lines, they are not moving outside the region of the core, so they remain inside the core, and such magnetic flux lines, as they change with the change in the input voltage and current, so such magnetic flux lines will also change inside the secondary coil. So whenever magnetic flux lines changes inside the coil, it produces the induced EMF. So this is actually happening, and this is the phenomena which is called as the mutual inductance. So now this is the diagram for the step up transformer. Here you can see that the number of coils on the primary side, they are less as compared to the number of turns in the secondary coil, and here you can see the voltage cycle. Here this is the amplitude of the voltage, input voltage, and that amplitude is been increased. It means that voltage is up, so it is called as a step up transformer. While this is the symbol for which is commonly drawn for the step up transformer. So for the primary winding, then there is a magnetic core and the secondary winding. So here remember always that the number of turns for the primary is less, and if the number of turns for the secondary coil is more, then such transformer is called as a step-up transformer. Then for the step-down transformer, exactly the reverse condition takes place. That is, on the primary side the number of turns are more, and on the secondary side the number of turns are less. So for the step-down transformer, here you can see the voltage cycle. Here amplitude of the voltage is large, while at the output side here the amplitude is reduced, means it is step down. So this is usually the symbol of a step down transformer. So on the primary side the number of turns on the coil is more, on the secondary side the number of turns of the coil is less. Then we will discuss a few questions which are related to the topic of transformers. So the question 1, that is the transformation ratio in a step up transformer is, and the options are A, 1, greater than 1, less than 1, and D, that is the ratio greater or less than 1 depends on the other factors. So it is obviously step up transformer. So for step up transformer, you know that the transformation ratio is always greater than 1, because we have seen what is the transformation ratio is. The transformation ratio is defined as Ns upon Np. So for the step up transformer, the number of turns of the coil in the secondary coil is more than that of the number of turns of the in the primary coil, and therefore this ratio is always less than 1. So it is always greater than 1. Then the second question, in a transformer 220 volt AC voltage is increased to 2200 volts. If the number of turns in the secondary are 2000, then the number of turns in the primary will be. So here you have given that in a transformer 220 AC volt is increased to 2200 volts, means this is my output voltage, that is my Vs, this is my Vp. Then the number of turns in the secondary are 2000. So if Ns is given as 2000, you have to find out the number of turns in the primary. So we know the ratio, that is Es upon Ep, or we know that this relation, that is Es upon Ep is equal to Ns upon Np. So this Es is given, Ep is given, and Ns is given. You have to find out what is Np. So 2200 divided by 220, it is equal to 2000 divided by Np, that is number of turns in the primary coil, and therefore this ratio 2200 divided by 220, that will be near about 10. So 10 is equal to 2000 divided by Np. So transferring Np on left hand side, we get 10 times Np is equal to 2000. So dividing 2000 by 10, we get the answer as 200. So it is simply 200. So correct answer is A.